Hello and welcome to my first ever YouTube video. On this channel, we're basically going to be discussing and going through brief tutorials for automations using both AI and non-AI tools. And so yeah, for today's automation, we're going to be automating the Lighthouse API, which is basically what runs under the hood of this pagespeed.web.dev website. It's an analysis tool for websites, and as you can see here, it's currently running through basically diagnosing performance issues. It's going to come back with other results like for SEO scores, accessibility scores, best practices. As you can see here, we've come back with a result of that. That took maybe 20 seconds to run through. So if you wanted to collect a bunch of scores for a bunch of websites, or maybe you wanted to run this on a daily basis on several websites, or if you had an e-commerce store and you've got loads of products and you wanted to check each page and check how each of them is doing, you could use this automation. And what it's going to output is something like this. As you can see, we've got run through and done 500 URLs. These are all different ones. I just grabbed a list from the internet, but you could put in whatever you wanted here. So we've got the four main scores that come through, and then any of the other data that's underlying is also available. So you can see in here you've got all of like underperformance. You'll have all of the stats and metrics that are underperformance, including suggestions. So that's something that you could extract in this to show you that the data is there. I've extracted one field because I'm not doing it to solve a specific problem. I've not put more in here, but you can get access to any of this information which is shown here. And just to quickly go through a couple of the use cases for this product. So for example, we could have an e-commerce store. It's got thousands of products, and obviously each of the products has like a page on the website. What you could do is you could input all of these URLs into the automated tool, go through, check them all on a monthly basis, on a weekly basis, however often you wanted to do it, and just ensure that all of your pages are loading quickly. You could also have a digital marketing agency. The digital marketing agency could be providing SEO and website optimization services to a variety of clients. And yeah, the agency can improve the client's website rankings by effectively checking all of their clients' websites on an automated basis. And yeah, finally, for a web development agency, they might have had 100, 200 clients in the past, and they might have to be managing all of them for a retainer fee or something. And Google does change its scoring rules and stuff. So basically, this tool could be used to manage a large number of websites without having to actively put in work to check them on a regular basis. I'm gonna show you how to do the automation, but I don't want to show you how to set up all of the boring stuff. So I'll chuck up on the screen some prerequisites that you're going to need installed on your computer, or set up on like Google Cloud and stuff, because we're going to be basically putting the output as a report on a Google spreadsheet. And yeah, that report on the Google spreadsheet, we need to activate some Google Cloud APIs, which basically let us use code to speak to the Google Sheet. So yeah, I'll chuck those prerequisites up on screen, and then
Yeah, so the prerequisites for this, you're going to need Node.js installed, you're going to need Python installed. 3.11 is the version I used in this tutorial, so it's probably best if you just use the same version, but any future versions will probably also work. Yeah, you need a Google Cloud Platform account set up, you will need the Google Sheets API activated on the account, and you'll need the Google Drive API activated on the account, and you'll also need to download a service account file with minimal permissions, which can be done with 0 roles.
So now, assuming you've met all the prerequisites, we can crack on with what we're doing. I've just got Visual Studio Code open here. I've just opened a new directory on my Mac. There's absolutely nothing inside it, so we're just going to begin from scratch, and we're going to head towards getting this project started. So the first thing we're going to want to do is, I'm using Python 3.11. You can use whatever version you like, although I suggest trying to use the same or a more modern version. as the tools will be just slightly more up to date. Okay, and then so we're going to use the virtual environment module to create us a virtual environment. This means that all our libraries will just be installed locally, and then we are going to activate the virtual environment like this. We can see that it's now activated. So now when we start installing some of the tools that we need, they're going to install them locally in the Python environment rather than system-wide. Also lets us bundle up the requirements into a requirements.txt file so that if I was to download this project on another computer, I can just immediately install the requirements that we need. So the first thing we're going to need is gspread. That's for interacting with Google Sheets. We're going to need Google Auth. This is going to be for authorizing our communications with Google Sheets, and it looks like that's already been installed when we installed gspread. Cool. And install pandas. I'm just going to grab some data off the internet just to run the test with, basically. And the reason why we need Node.js installed is because of this package. We need Lighthouse, which is, like I said, the page speed insights is originally called Lighthouse, and this is a Node package, and I'm going to install it with -g, which is the global flag, so that that is going to install system wide, and we're basically going to use it as a command line tool. So Lighthouse -- version. Yeah, so we can see that it's successful. I already had it installed, but once you've installed it, just make sure that we can run it by the command line, because that's how we're going to be calling it from our Python script. Yes, I guess the first thing to do is we're going to want to write some code to interact with Lighthouse itself. So let's just create a class. We'll install modules as we need them. We'll call this Lighthouse audit. What we're going to do is we're going to write some reusable code, which we will be able to effectively so we're going to write some reusable code, which we're going to want to, this is going to want to process one URL, and then we're going to want to effectively use this code for each URL that we have, so that we can store them like that. What I'll do is so the way the Lighthouse tool works is it actually downloads a JSON file. So what I'm going to do is I'm going to set an output directory. I'm just going to put that as --lighthouse. So that will store all of those in there, and then we're just going to go if not. Okay, so yeah, if not os.exists brackets self.output directory os.make this self.output directory. So set output for Lighthouse, and then if it doesn't exist, we create it. Okay, and then we're going to import OS here because we're using that. OS lets us touch on use our operating system, gives us an API to do that. So yeah, when we call it now, we're going to initialize it and create a directory. You can see we don't have the directory, so if we actually go, we'll just call it LHA equals Lighthouse audit, and then I've been doing too much React. I don't need to put line ending characters, and then we're going to just run the script here, Python lighthouse.py. If os.exists, oh yeah, that's correct. It's os.path.exists. There we go. And then we can hit rerun that. Cool, so that's successfully run. You can see it's created the directory because it doesn't exist. Now the directory does exist, so this code would be redundant, but once again, if we take this code and then start running it on someone else's computer, it means that they won't run into errors running it. And then yeah, this is the second part, I guess, is just to run Lighthouse. So what we're going to do is self, and then we're going to run it on a specific URL. runs node runs Lighthouse CLI, and the Lighthouse CLI does save the output to file, so we don't need to do anything about that. So we're going to go timestamp equals datetime.now, and then okay, let me from datetime import datetime. This one's a little bit of a confusing import because it's importing the same name from itself, but yeah, datetime is nested inside datetime. So yeah, datetime.now, and then we're going to want to do the striff time. I don't know how you're supposed to say that. And then yeah, we're going to want to just go %y, I'll make it a string, %y, %m, %day, %h, %m, %s. What that's going to do is that's basically going to give us a timestamp where it's the year, month, day, hour, minute, second. So we're going to use this to save the file, because if we run the script once and then say we want to run this every day, it might be a bit overkill for a script like this. But when we're running the script, we want to basically save the timestamp with it so that we can get the most recent record, or we can see how it changes over time, stuff like that. Okay, and then we're going to go for an output file name. This is what we're going to save the file as. It's one of the arguments for the script. So we're going to go create user f string output directory, self.output directory. So that's going to put it in our newly created Lighthouse, and then we go dash, and then we're going to go url.replace. What we're going to do here is we're going to remove any of the let's change this to this, this to this. You're going to replace any of the dot replace. Let's pop that at the end. I want to replace a / with we'll just replace it with an underscore. And I'm also going to replace a dot with we'll just replace that with a dash. Okay, that should be our output file name. And now we go command equals f string Lighthouse, and then URL. And then we're going to go dash output JSON dash output path, and then that's going to be our output file name there. Okay, and then subprocess.run command, and then we're going to want to import subprocess, which this basically lets us, similar to the OS, this is another local library. It comes with the Python standard library. We don't need to install anything. I don't know why this is complaining. Oh yeah, so it comes with the Python standard library. We don't need to install anything. We're just gonna yeah, so subprocess is just going to run the command locally, same as how OS lets us access our operating system API. This will let us run the command. Cool. And then we're going to return the output file name as well. That's just so we can use it. Oh, and we should put this at the end of here. We're going to put underscore timestamp, but we need it to be f string concatenated. Cool. And then that should be good there. And then let's go LHA dot run Lighthouse, and let's go https / we'll just use Google for now, and then let's try rerunning that. We should, and we're going to want to go output equals output file name. We don't need to collect that for now. In fact, no, we will collect it. We're not going to do anything with it. We'll print output file name. No such file or directory. output path, Lighthouse, Google. Oh, okay, so we missed out. Oh, yep, so I missed out shell equals true. We were just trying to run that as a file or directory. If we pass it the shell argument, then it will run it inside of a shell as a command, which is what we want. So it should now work. Yeah, we can see from where we test ran it there, it's already there. Okay, so it's navigating to Google, and there you go. So it's written that the most recent one is this one. So let's just delete this. Yeah, we'll get rid of that for now. Okay, and we can see that we've got the data in here. This is what was displayed on the user interface of the website here. It's the same data, but this is in JSON format. Obviously, the reason why we use a user interface like this is because it's way easier for humans to understand than this. So what we're going to have to do is we're going to have to extract the data that we do want from here. So I think what we're looking for is we're looking for performance, accessibility, performance. Just do this, performance. Oh, is it? Okay, I will figure out where these are and then replay the video once I found them, because looking through that doesn't seem that fun. Okay, so we need, okay, yeah, so we're going to need another function, which is going to be to process the output self JSON file. Takes a JSON file from the Lighthouse output and extracts useful information. Okay, so yeah, this function here is going to basically take this JSON file. It's going to read it. So we want to, with open JSON file, we're going to just take it in read mode as f. So we open it here. Data equals JSON.load f. Okay, so we need to, and this is another built-in module, is the JSON module. So we're interacting with JSON data. So we can just use the JSON module to do that. It comes with a bunch of handy things we can use. Okay, and then we're gonna, oh yeah, so we're gonna use a try statement here with an except. We're gonna use a try with a bare except, so that when we except okay. Okay, so what we're going to do here is we are going to get the, we're going to go data categories, data categories, performance, and then we're going to go for score. So what we're going to, and then we'll just call this performance equals this. So what we're doing here is we're basically going through this JSON, and we're going to extract the 4 key values here. There is a bunch of other data that we could go in and get, but for now we're just going to stick with those 4 values. So we're going to go for accessibility equals, and then we'll just copy this same thing. We'll just go for accessibility there. The same with this, we're going to go for, what are they? Best practices in SEO. So best practices, and SEO. Okay, so this should give us the 4 scores. What we're going to do is just check that that's worked. Do this. Let's make it a little bit prettier than that. Let's go performance like this, space like this. Do this, do this, do this, do this, do this. Make it an F string. Okay, so this should make it a little bit prettier to look at. And then we'll just go accessibility, best practices, and SEO. SEO. Okay, so we're gonna run this, and that should run the headless thing. We can see that the Lighthouse tool is running in the background. Navigating to Google. It's going to save another file up here. We can see the second one saved, and this should pass it and print it. Okay, so that didn't work because we never ran this function. Okay, so now we should do LHA dot process output. Cool, and then we take this output file name, chuck that in there. We don't need to print the output file name because now we're processing it. So we'll just run that again. Okay. Yeah, so this should now process the output. We can see that it got up to the right point, and then we should be able to see whether we get out these values or not. Should process them. Cool. Okay, so it's actually what it's done is it's put this as a decimal. Ideally, we want values like on here. We want like 100. So we're gonna just do times them by 100 there. What that will do is that will just give us much easier to understand percentage values, basically. They're exactly the same thing under the hood, but just look a bit nicer. And what we'll also do here is, this is a dangerous way of accessing data in Python, because if, for example, score or performance or categories is null, so the response from the Lighthouse tool was broken, it wouldn't work. So we're gonna perform some error handling here just to make sure that it's going to work. So we'll do if categories and data. So what that's going to do is that's going to check to see whether the categories field exists. And then we go if, in fact, let's go performance data equals data categories dot get. So get is a method that's a safe version of accessing something like by indexing like this. So we're going to do .get performance, but then get allows us to, or the get method allows us to add a second argument, which is this empty dictionary. So what this empty dictionary will do is, if the performance value is null, we're actually going to just get an empty dictionary out. And then we'll do the same thing. We'll do performance equals performance data dot get score, which we're going to once again safely use the get method, which will, if score is null, then we return none. If we access it like this, it will throw an error, and oh no, it won't throw an error, it will return none. Well, it depends. If it doesn't exist, it will throw an error. If it's a null value, it will sneak past. Actually, that's not objectively true. If this field doesn't exist, it will error. But if we do .get, it will return none rather than erroring. Yeah. Okay. And okay, so we got get score none, and then we're just going to times it by 100 if score in. Okay, and then so this is a safe. This does the same thing as this. This code here does the same thing as this, but this is a safer way of doing it. Else we should set performance equals none, not double equals none. Yep, accessibility, best practices, and SEO. Okay, so if categories doesn't exist, then we just set them all to none and continue our way. Because we're processing loads of things, we need to make sure that we don't have errors. Super important. So, and then we'll just do the same thing for all of these basically. So I'm just going to copy and paste this underneath. and we'll just go accessibility data, accessibility data, accessibility. Yep. Make sure that they're all replaced there. It's important they're all done. And then same, we'll go best practices data, best practices data, best practices, except I think there should be best dash practices. Yeah, you can see here. Best practices there. And the final one we're going to do for SEO. So we're going to go for SEO. SEO data equals get SEO equals SEO data dot get score if in SEO underscore data. That should be best practices underscore data. Let's just give these a quick once over. That looks good. That looks good. That looks good. SEO data. Yep, cool. So this should do the same thing. So what we can actually do here is we can just comment these so that they're not running. We'll keep them just so we know what we're running off of, and then we just run it quickly. So we should hopefully see that this is going to give us the same values out without causing us any errors, but the error handling here is going to be better, meaning that if and they're all times by 100 now. So we've got nice round values to work with. Perfect. So this is effectively done. In fact, you know what? While we're here, what we'll do is if we go in one of these, if we were to get out some extra data from this, I've picked these four because they're the four main ones, but there is all of this data, all of these other values are within this JSON, and you can see it's giving useful information like telling you how to improve your page, how to improve your rendering time, which can be super valuable to potentially tell a client how they can reduce their page load time, or even if you're a web developer, how you can do that yourself. So yeah, all this information is here. So what I'm going to do is I'm just going to dive into the data really briefly, and we'll pick the first thing that there is. So, okay, yeah, so we've got data.audits is on https.score, okay, and that's a binary. Okay, so basically we're going to add this as well to our output. So let's quickly write that out. So I've got it. It's audits, data, audits is on https score. And then we know that Google is on HTTPS and it's got a score of 1, which is true, so that's good. So equals 1. If it equals 1, then true. If it's 0, then it will be false. So we should print this, and this is using HTTPS question mark. And then I'll just close this and put a comma. We won't bother with an F string just there. Okay, and then we'll implement this in a second, so we'll just rerun this briefly. And what this is going to do is this is going to effectively show just that we can modify the automation to include, as you can see, there's nearly 9,000 lines, but we can extract any data. And yeah, you can see down here is using HTTPS true. So we can basically take any of this data that we got from the Lighthouse. For this example, we're going to use super simple data, but maybe you want to focus specifically on performance because you're focusing on the performance of all your clients or something. So yeah, we can just extract more data like this. What I'll do is I will make sure, so we go I'll add some error handling to this, and then I'll add that one on the end as well. So if audits in data, then we go HTTPS data equals data audits get is on HTTPS, and then we do this, chuck that on the end. So yep, so we get that, and then we go is HTTPS equals https data.get score, and then none if score doesn't exist, times, we don't want to times it by 100 for this one because this is a binary value, it's either going to be 0 or 1, and we go if score in https data else none. Okay, and then we go is https, and now I think that's us done. So what we're going to do is we're going to actually return all this data. So we're going to return performance, accessibility, best practices, SEO, and is HTTPS. And then what we'll do is we'll just to check that that's working, we'll do this, do this, do this, do this, drop that there. We're going to print performance, accessibility, best practices, SEO, and is HTTPS. Okay, and so now we've got them, and what we'll also do is we'll chuck this URL into a string, and then we'll go URL, we'll go stats for URL, and we will, we'll use f string for now. Stats for URL, we'll just go website, chuck an f string on the front of that, and then while we're running that, we'll just briefly chat about what we're going to do next. So now we've got it working for one site. We've wrapped this inside a class, so we've made like a really reusable piece of code where we can run Lighthouse, we can process the output. I can get rid of these comments now, and we can process the output and then get useful information from the output and then return that. So yeah, we can see that that's working. We've got a 1 is HTTPS 1. Oh, so maybe, yeah, we can see that this is actually returning 1. If yeah, we'll just put a greater than 0 here. What that should do is we are saying that, yeah, that's probably the easiest way of doing that. If it's greater than 0, then it's going to be true, which means that HTTPS is true, right? So we'll just rerun that. Yeah, so the next stage while that's running is going to be integrating this into a useful output so that we can pass it to a client or just generate a report. What we'll do is we use Google Sheets for that. Google Sheets is like my personal favorite for throwing things in because it's super easy to spin up. You can kind of send it over to anyone. And it's got really, really nice integrations with Python. Okay, cool. I've just been to grab myself a coffee and we'll crack on with continuing this. So yeah, we're done with the Lighthouse code, so we can remove this. And what we're going to do is we are going to jump straight onto writing the Google Sheets interactions. So Google Sheets is going to be using GSpread. We are going to also be using the google.oauth2.service account, import credentials. So what you're going to need here is you're going to need your credentials or your service account downloaded. What I'm going to do is I'm just going to briefly pause the recording while I get my credentials over. What we'll do is I'll put them in a folder called keys. Cool. So okay, I'm back. So I've chucked in my file here. This is my, so I'm going to go into my keys, and what I'm going to do as well, actually, while we're here, I'm just going to add a get ignore. I'm going to go ignore the virtual environment, ignore the keys. So when I do, and I also have a dot history. This is, you don't need to add the dot history. I have a plugin on VS Code, which is basically saving a local history of all my files, but you don't need to worry about that. I'm also going to just get rid of all these for now. They're not really needed. So yeah, this get ignore will basically, when I do go to save my files to GitHub, to save the code, I'm going to ignore the keys because we don't want to be uploading any information like that. Because obviously someone else could use it to connect to our account. Okay, And okay, we're going to have Google Sheets, and we're just going to call this here. So we're going to once again using the init. What we are going to need self. We will also do a spreadsheet name and a sheet index, which will set default to 0. This is if you've got multiple sheets in a Google Sheet. We won't have it for this instance, but you do need to select the sheet anyway. Okay, and we'll go self dot credentials path. Now you could pass this over, pass this in, which is probably the best way to do it. Once again, if we're trying to run this on a different computer, then if we're trying to run it on a different computer, we want to pass in the credential path so that then they could, if they called their folder secret and then they put it inside there or something, they could just input that. So equals spreadsheet name self.sheet index equals sheet index. And we're also going to initiate the other things that we need. So we're going to have a client to interact with our Google Sheet, and we're going to have self.sheet equals none, because we don't, the sheet is what we'll be interacting with. The spreadsheet name we'll use to get the workbook, which will have sheets in it. And yeah, this is what we'll actually be interacting with, the client and the sheet. Okay, and then we're going to need to authenticate. So authenticating function to authenticate and set scopes. Okay, so here we set the scopes of the access. So the scopes are going to be, I will just copy and paste these from the website open. So we're going to basically need access to two things. We're going to need access to the spreadsheets API. This will basically allow us to modify spreadsheets or to modify Google Sheets and the Google Drive API. Because what we're going to do is we are going to create a spreadsheet if it doesn't exist. Just for this example, each use case you end up finally using it for might be different, but that's what we're going to do in this case. So from service account, file, and then we have self.credentials path, cool, and then self.client. So where we initialized the client to none earlier, we are now going to authorize using the credentials that we've just created, and the scopes need to be passed into the credentials to authenticate with those credentials. And then I think the first thing we need to do is we need to try and get the sheet. So what we're going to do is we're going to go open sheet, self, and then we will do this using a try except statement. And what we're going to want to accept is we're going to want to accept gspread dot what's it called, the exception. I'm going to have to quickly Google this and figure out what exception we're looking for. Give me 2 seconds. Gspread errors. Yes, so we're going to use spread dot exceptions dot spreadsheet not found. Okay, I think that makes sense. And then so we're going to go self dot spreadsheet equals self dot client dot open self dot spreadsheet name self dot sheet equals self dot spreadsheet dot get worksheet self dot sheet index. So yeah, basically what's happening here is we are opening the spreadsheet name, which we passed in here, and then we are getting this, because when you open a Google Sheet, you have multiple sheets within it. So we're getting the specific sheet, this in this case at index 0. And I think that's everything there. Oh, yeah, this self.spreadsheet we never actually defined up here. So let's just do that. Equals none. Cool. And then yeah, when if this exception happens, if the spreadsheet's not found, then we're going to want to actually create a spreadsheet. So we're going to need to create another method for that, which we'll do in a second, and then we're going to do the same thing here. And then we're going to print open sheet with URL spreadsheet.url. What that's going to do is just self.spreadsheet.url. What that's going to do is basically tell us the URL of the sheet that we've opened. And we do need to create this create spreadsheet function now. Create spreadsheet. That's self.client.create self.spreadsheet name. Okay, and then yeah, we just do self.create spreadsheet, which will create the spreadsheet, and then we can open the spreadsheet and use it. That should work. To confirm that that's working, what we'll do is we will initialize an instance of this. So we'll go js equals Google Sheets. We need a credentials path, so we're going to do keys dash gsheets key.json. We need a spreadsheet name, which we'll call Lighthouse Audit. We don't need the sheet index because it's set to default of 0. If we were going to select the first page, we need to do something different there. We can do js.authenticate, and then we can do js.opensheet. And then we should, if everything goes successfully, we should see this open sheet with the URL. So let's go python gsheets.py. Okay, yeah, so this is done the sheet, and we can see this URL here. When we open this, this should not let me get access to it yet because I'm signed in using my Gmail and we haven't invited us to it. So the next thing we're going to need to do is we're going to need to do a invite user to sheet, which is going to self, and then I'll pass the user in. Self.spreadsheet.share, and then user. This is going to have to be, maybe we should do this as email. I think it makes more sense being email than user. Type equals user, role equals writer. Now here you could transfer the ownership of the sheet to this user, but that would mean that the script didn't have access to it anymore. So for now, we'll just do it as writer. And then, yeah, so if this all works properly, once we've opened the sheet, we also want to invite user to sheet. Js.invite user to sheet. And then we're going to do, this is my email that I'm currently logged in with, .com. Okay, and then just hit that again. Oh, maybe we'll go print invited user to Google Sheet. Okay, so that should have run now. We can check it. We don't actually need the print statement. And then there we go. Okay, cool. So we've created the Google Sheet from the code, and you can see that it's opened, and I have write access. I should be able to write things in here. Hello. Perfect. Cool. Let's get rid of that. Okay. Okay, so now we've created the sheet. Now, the final thing we're going to want to do is we're going to be def update sheet with Lighthouse audit. And then we're going to self the data from the audit. I'm also going to chuck in the headers. We'll chuck in default values for them. We'll allow an overwrite method. So the headers we're using are performance, accessibility, best practices, SEO, and is HTTPS. So performance, we've got accessibility, we've got best practices, and this is going to be SEO and is HTTPS, and this is going to be the headers that we have at the top of our sheet. So at the top of the Google Sheet, we'll see that. We will actually going to need the first one as well, which will be the URL or website or web domain or whatever we want to call it. And then we're going to do, so this is going to be effectively doing the whole thing that we've done below. So we're going to self.authenticate, we're going to go self.open sheet, self. So we're going to need to do self.update sheet. We're going to pass the headers and the data and print successfully updated sheet, and then self.invite user to sheet. Now, I'm not sure the best way to go around this. We don't really want to be inviting user every time, but we've already invited ourselves, so it should just work for now. So we'll just leave that out for now. Actually, no, we'll pop this in for now. And we'll just check on the end, user equals, I'm going to put in myself for now. Okay, and then we'll just chuck in user in there. And this should be self.invite user to sheet user. Okay, perfect. So this is going to do all of the things that we want to do. We do need an update sheet method, which I forgot to write. Self headers data. So self.sheet.append row headers. Self.sheet.append row data. Append row data. And that should just go through and append all of those to that. Okay, right, so we can get rid of this now. What we'll do is we need to test that this has worked, but to do that we're going to need some data from the neighbour's taking the bin for us. That's very kind of him. So we can do that. We're going to need some data from the Lighthouse script. So let's just jump in the main.py Lighthouse script. Well, main.py, so we'll go from Lighthouse import, what do we call it, Lighthouse audit, and then from G-Sheets import Google Sheets, and then go def main, we'll just pass for now, if underscore name equals main, and then we run the main function. Okay, and now we are going to want to, first of all, we're going to want to use that Lighthouse logic. So we need to go Lighthouse audit equals Lighthouse audit. I don't think we needed anything to initialize it because we just set that the output directory is this. All good. And then we just want to run Lighthouse and then process the output. So we go run Lighthouse, and then this we need to pass a URL. So let's just go https google.com. Doesn't really matter what we're running on it. And then we get the JSON file equals this, and process output JSON file. Okay, and then I think from here, this is going to return our values. So we're going to go data equals, let's once again abstract this away, URL equals this, we chuck the URL in here, data equals URL plus result equals this, URL plus result, and then let's just print data just to make sure we're doing it right. Okay, it's going to run the headless Lighthouse that we set up earlier. And hopefully, okay, it's written the output to Lighthouse, we've got it there. URL plus result can only concatenate list, not tuple to list. Print result. Oh, I think the result of this is actually these, isn't it? Yeah. Okay, yeah. Okay, so we actually need to do, it's a tuple. They're all commented together, so it makes a tuple. So what we actually want to do is we want to do comma space that, and that will, apologies, this just turned on. Let me just turn this off. Dehumidifier is in the room right next to me, it's just turned on. Yeah, so what we want to do is we want to concatenate them into a list, and then print data. So this should show them all next to each other this time. And then what we're going to want to do is we're going to want to basically get a list of URLs and go for URL and URLs, but we want to first of all check that this is working. So we can actually chuck this back open. We'll grab this to go in here. Okay, yeah, so that worked. Cool, good, happy days. So now we want to do gs.update sheet with Lighthouse audit, and we can just pass in the data here. Hopefully that will just work. We'll find out very shortly if it will. Yep, okay. JSON and output are in here. It's done that. Let's put we have got a message, successfully updated sheet. Okay, yeah, so that's just worked, which is good. So now we've got this, we've updated one. There is one thing that I think that we need to do. What I'm going to do to keep it really simple for this task is I'm actually just going to, inside of here, I'm going to go self.clear sheet. Normally we wouldn't want to be potentially overwriting everything, but for this example that works absolutely fine. Self.sheet.clear. This needs self. Okay, and that will basically, because otherwise what we're going to do is we're going to end up rewriting all of these and rewriting this. So that will now clear the sheet each time we go through. We have some data in there, which is great. So let me, yeah, that should be working now. Everything should be good there. So the only thing left to do now is going to be to grab some more URLs and then just go through them in a loop. So let me pause the video quickly while I go grab some URLs from you. Gone and grabbed the first set of URLs I can use. They're the most popular URLs in the world, apparently. There's 500 of them, a bit excessive for what we're doing. It's 500, yeah, 500 of them, including that. The titles, but yeah, it's a bit excessive for what we're doing, but basically I'm just going to grab these URL collector.py. Okay, so the best way to deal with URLs is just going to be to, so we'll go data, is to use pandas. Just effectively is a way of editing tabular data in Python. Super popular tool, lots of kind of tools built around it. But yeah, it's going to be, as you're going to see here, it's going to be very easy for me to select the things that I want. And then we'll just go print df.head, and then I can just go Python URL collector. 3, 2, 1. Hopefully that works. Okay, yeah, so we can see that this data is successfully loaded in. Okay, cool. And then we are going to go list of domains equals. So actually, I should rename this because this isn't actually, these are domains. So I'm going to rename them as domains.csv because they're domains, not URLs. So we're actually going to have to do a little bit of manipulation on this to make it work for the Lighthouse tool. I think they're going to need to be HTTPS encapsulated. So df, and we can see root domain dot to list and print list of domains. And then what we'll do is we'll just print 10 of them. I don't need 500 yet, so you can see here. Move my head out the way. Move this. Yeah, it's just pick 10 of them. Super easy. Cool. So we got 10 domains, and what we'll do is we'll actually stick with 10 for now. I can 10 domains equals this. Yep. So we've got our 10 domains, which we've got here, and then what I want to do is I do want to domain to URL equals. What I'm going to do is I'm just going to chuck HTTPS : plus domain for domain in 10 domains. I'm actually going to call this reduce domains because I might want to modify this later. Okay, and I'm just going to make this a function for now. Get some domains, and I'm going to go number and then 10, and this will allow us to get 10 domains. But just to do that, domain to URL equals this, and then we want to return, let's call this URL list, return URL list, number, no, equals 10, not : 10, type ins, I mean we can include type ins, but I'm not doing that for this for now. Okay, so we got get some domains. Let's just make sure that's working. Get some domains. Do that again. Oh, we should print get some domains. Just make sure that we're getting 10. Cool, that is still pulling for 10 domains. So now we can go from URL collector import get some domains. And then what we'll do is I should rename this to get some URLs. Get some URLs. Okay, do that. Go here, go into main, get some URLs. Now we're going to go URLs equals, and we're just going to use this function that we made, get some URLs. Go for URL in URLs. Do this. Ooh. Okay, and what we'll do is we'll combine all this. All data equals an empty array. We go all data dot append data. Okay, and I'm not sure what's going to happen here. I'm not sure if I've written the code in a way that's going to let me chuck a list of. Oh, I am running the wrong file there. Yeah, I'm not sure if we're going to have to make a modification so that we can chuck effectively a list. We're making a list of lists here. I don't think we can just chuck that at this. We'll see what happens. So this is going to run for 10 things. I will. It's going to come through with all of them here. I will come back when it is done. Won't take a super huge amount of time. As you can see, we've already gone through a couple here, but I'll come back when it's ready. So yeah, it's the code has just run. We've run into an error hitting the Apple domain. It seems like we have an issue with in this line of code, which is to do with accessibility. So that'll be in Lighthouse in accessibility here. Okay, so I see. So what's happened here is this is evaluated to none, and we've tried to times none by 100, and it's gone. You can't do that because trying to times none by 100. So we need to add a check in here to basically make sure that if it's none, we don't times it by 100. So what we're going to do is we will just add another step in here. We'll just go accessibility, we'll go if accessibility score, we'll do this, accessibility equals accessibility score. So this is a mouthful. Score times 100. Oh, else accessibility equals none. Then we'll just chuck this one on here. Do that, do that, do that. Okay. Oh, I've clearly got some spelling issues. Okay, so what we're doing now is we are checking before we multiply it by 100. We're going to check if it's not null, and we should do this for all of these. So even though we put this error handling in, something's managed to slip through, which is fine. That's what programming is about. Best practices score. Chuck that in. Done. Best practices. Best practices. Blah blah blah. And then this one should be SEO score. SEO score. SEO score. And this one should be performance score. And just to make sure best practices SEO score, SEO, blah 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 blah. Okay, that should get rid of that error. And we have down here, do we need to do the same thing here? We're not timesing it by 100. We are comparing it to 0 though, so we should do the same thing here. We should go score if is HTTPS score, then we do is HTTPS equals HTTPS score greater than 0, else is equals none. Cool, let me remove this comparison here. Okay, so what that's done for us is we should have some better error handling in here, so we can just rerun this, run through and come out with hopefully a working output. Cool. So yeah, I think that's everything we need to do for all of these. Yes, I'm just gonna pause there again and come back once this is run and we can have a look at where we're at. We ran it and realized we forgot to take out these times 100, so just remove all of these and hopefully it'll work. Cool. Okay, so I've rerun the code and basically it seems like we have a issue where we're passing a list to it, which is what I thought might happen, passing a list of lists to this, because this basically takes data and goes sheets.append row. So let's go if data 0 equals list. So if the type of data 0 equals list, let's put this underneath here and move for list in data. Okay, so this hopefully should modify that. Well, let me rerun that now and I'll run through what this has done. So we basically check if the type of the first element is a list, then we know that we've got a list of lists. Otherwise, we know that we've got a single list because those are the two types we want to pass to it. So hopefully this should work and allow us to both take a list of lists and a list. find out. Oh, it opened the sheet. It successfully updated the sheet. Let's have a look. Hey, okay, so that's worked. We've got two. They're both HTTPS. We've got performance scores from them. Incredible. Okay, I think that's pretty much this done. So we can now what we can do is we can go back to this main. I reduced it to 2 URLs. So let's do something chunky. Let's chuck in 25. This will take a second to run. So I'll start it running in the background. And what this should mean is that we can chuck 25 URLs, and then we've got a list of 500. So obviously this has taken us a couple of hours to probably go through and make this automation. But what this would mean is that in the future we can go through 500, 1,000, an unlimited number of URLs and gather data from them. We can extract any data that's within this page, which is obviously this page, so we can extract any of this data. And with this data, we can do what we want. We can put it in a spreadsheet. We can start combining it with other data sources, potentially using like the data for SEO APIs or the Moz APIs to enhance what we know about these URLs. This could obviously be super useful for a digital marketing agency or a web development agency. It basically stops you from having to manually go through and check all of your clients or your leads, websites. You can just generate all that information and chuck it in a spreadsheet, either for yourself or to give to your clients as part of your product offering, whatever that is. So yeah, we'll just hang around till this is done, or I'll pause the video till this is done, and then we'll have a look at what that looks like. Okay, yes, so it's just run through, and basically we've run into another bug. This is perfectly fine. Basically what happened was the Lighthouse script that was running under the hood, the node script basically timed out waiting for the page to load. What that means is that we have to do something to make sure that if this doesn't work, that's timed out and then basically not saved a file, and then we've gone to look for the file and it's gone, oh no, there's no file. So what we need to do is we need to, in this process output, where the file is looked for, we just need to add a try catch thing here. And then if this fails for whatever reason, so we'll try and then we'll accept, and we're going to accept the specific error, file not found error, file not found error as E, and then we're just going to return none, 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 none. 1, 2, 3, 4, 5. I'm just going to leave it as this for now. Normally what we might do is we might flag that URL for reprocessing or something. What I'm going to do is I'm going to set them all to none, so that the script continues. In a more complicated, comprehensive script, we would add it to a list to reprocess or something along those lines. For the sake of this, we're just going to return none for everything, just for simplicity's sake. Okay, cool. So the changes we made to the script worked, and it's run without bugs. So let's just quickly step through to this. Oh, we've already got it open 3 times. Oops. Okay, yeah, so it's run through. We can see that it's run all 25 URLs. And some of them have got errors. I think this is due to like authentication and stuff. You can see that it redirects and logs me into my account. I'm pretty sure that, yeah, so I tried it for the docs.google, and you can see that it redirects it to an account sign-in identifier. So it's basically trying to log in. So for some of these, obviously they're bad URLs. If we were actually picking websites that we could access, we'd end up with results for all of them. Same for these ones. I'm guessing you have to be logged in to do things on them. So yeah, as you can see, the script's run. We've generated 25 results. We could go through and we could keep going through all of these and generate results for all of them, which is, yes, we could go through, generate results for all 25 URLs. or all 500 URLs and keep going. So this automation would obviously save you time on doing that. We could expand it to include more information from the JSON file. But as you can see, the power of the automation lets you check through hundreds of them at a time. And then what we could do is we could even add some conditional rules in here. We could add, like, if this value is, the performance value is greater than 60, then we want to send a notification to the client, or we want to add that as a lead that we want to chase, if we were looking at lead generation. So there's various ways of using this data. So some of the improvements that we could potentially work with on the tool. One of the things that we could look at doing is parallelizing it or using asynchronous web requests, which will basically allow us to speed up the process a lot. Obviously, this is just an example. When you're doing that, you'd obviously have to be careful of, like, not breaching their fair use policy and ensuring that you didn't send 10,000 requests at once within a second or something. You could add better data storage. Currently, I've just chucked it in a spreadsheet because it's easy to show for this demo. But storing it in a database and then storing potentially historic data for each website, if you were scheduling it or something, would be cool. With regards to scheduling it, we could effectively schedule audits of a bunch of URLs on a daily, weekly, monthly basis, depending on your needs. We could create our own custom user face. Similar to the page speed insights, we could highlight the things that we just wanted. We could report on changes to scores, and we could set up alerts. For example, if we have a performance score of 90 plus for our website, and it dropped below 90 and we wanted to be alerted of that, if we were doing, say, a monthly audit, we could then immediately know when our performance dropped, and go from there. And we could also report on one of the things that the page speed does is it suggests improvements that you could make. So we could effectively create a report which suggested these improvements. So that concludes this video. Hopefully you understand a little bit more about what this automation does, how you can implement it yourself, gives you an idea of how it can be leveraged across various businesses to ensure that you're providing top quality services, and effectively providing your clients with the best service by automatically checking their web performance. If you've got any questions, feel free to pop them down in the description below or connect with me on LinkedIn. And don't forget to subscribe if you're interested in more automations and understanding how they can benefit your business.